Hello and welcome back. So let's go ahead and jump into our math challenge. So here we have the doubling tree. Okay, this is our challenge for the day. And we can see that we've got a tree here. Okay, of course, I tried my best. And we've got a couple of branches on this tree. In fact, we've got 1, 2, 3, 4. And the challenge with this, before we jump into the challenge, I'm going to tell you a little bit more about this tree. So it's got 4 branches here, and every year, each branch on the tree is going to split, okay? Each year it's going to split. It's going to split into 2 branches, okay? And our question for this problem is I want to know how many branches I'm going to have after 7 years, okay? And we can do a little quick example. So I've drawn my little mini tree. Hello. It's like little Groot, baby Groot here, okay? And I want to know how many branches will be on this tree after 2 years. And we can see that there's 3 branches. So after the first year, okay, each branch is going to split like that, okay? All right, we can count them, 1, 2, 3, 4, 5, 6. And then the next year, they're going to each split again. If we count them up again, we should count 12 branches, okay? All right? So I want to know how many branches will be on this tree after 7 years. That is our math problem. Don't go anywhere because up next we've got some questions regarding our segments, engineering tributes, and maker highlights, so stay tuned. Hello and welcome to our math solution, and today we're solving this problem, the doubling tree. So in this problem we are given a tree, and we know that this tree has 4 branches, okay? And each of these branches is going to split into 2 every year. And we wanted to know how many branches there were after 7 years, okay? So the first thing to do about this problem, and you remember we went through an exercise, is to realize that these branches split, okay, into every year. So this is actually a problem to do with powers, okay? So if we were to think about this, right, our result's going to end up being 2 times 2 times 2 times for every year, right? So for example, if we had 1 branch, in the first year we would have 2 branches. And then the next year we would have 2 times 2, which would be 4, right? And then the next year after that we'd have 2 times 2 times 2, which would be 8, right? So we can see that this problem is actually just a problem to do with 2 to the power of however many years, right? So for one branch, I can calculate how many branches there will be after so many years. So 2 2 to the power of y. Y is years. It's how many branches we'll have after 1 year, depending on how many branches we start with. Okay? All right? But we started with 4 branches. So we're going to actually have 4 times this answer. All right? So I guess we could write that as, let's write that as x for the number of initial branches. Okay, this is x times 2 to the power of y is equal to the number of branches that we'll end up with. Okay? And now I can just plug in 7 years, 4 branches. This is going to be 4 times 2 to the power of 7. Okay? And I know that 2 to the power of 5 is equal to 32. And I know that 32 multiplied by 2 is equal to 64. And 64 multiplied by 2 is 128. So that is our answer for this bit right here. So we're going to say 4 times 128 equal to B. And now we just got to compute this here. But that is going to end up being 512. So B equal to 512. So that is how many branches we will have after just 7 years. We started with 4 and we end up with 512 branches. So pretty crazy stuff, pretty cool stuff. But that's it, that is our solution to this math problem, 512. I hope that you enjoyed, and we'll see you in the next one.